This is the final video in this MYP Science Criterion C series, and I'll try to keep it relatively short and relatively sweet. It's about the final strand, explaining improvements and explaining extensions to your experiment. So with improvements, our goal are to minimize the errors that we identified when we were evaluating the method. In the method evaluation, I pointed out plenty of things that were causing experimental errors. So our improvements should be an effort to minimize those errors in the future. Explain means to give examples. So for each of these improvements, we should give an example. One possible improvement is to use a lighter string. Using a lighter string would remove some of the slack in the string that we mentioned was possibly causing an anomalous data point at 10 grams. Another way that we could solve the same problem to take away the slack in the string is to increase the IV quantities, the independent variable quantities. So instead of starting from 10 and counting up to 50, which is what I did, I could start from 40 and then count up to 80. And that should take away the issue of having slack in the string and affecting the acceleration of the cart. One thing you might think about is increasing the mass is going to make the cart accelerate faster. That's what we found in the experiment. So increasing the independent variable without making any other changes is going to cause a problem. It's going to make reaction time even harder to deal with because the cart will be accelerating very quickly. So one improvement we could make to help us deal with that is to increase the distance that the cart moves from 20 centimeters to 1 meter. That gives us a lot more time to prepare, and it will reduce the impact of our reaction time. Because the longer period of time that you measure, even though there is still some human reaction time involved, the human reaction time is a smaller fraction of the total time that the cart was moving. So it'll still be there, but it'll be less significant than it was before. Another way we could deal with the issue of the cart moving too fast is increase the mass of the cart. This is from Newton's second law. If you have something that's heavier, that means it's going to accelerate slower, assuming that the force is the same. So increasing the mass of the cart will allow us to have even more time that the cart is moving, so that'll help us reduce the reaction time. Now, even better would be if we could get rid of human reaction time in total. And there are a lot of ways that you can do this. I'll just point out one here. You can make a slow motion video of the experiment and have a stopwatch in the background. So that allows you to go frame by frame and see exactly at what time the cart was at different places. And because you're taking those measurements from a video, your reaction time is not relevant anymore because you can pause the video and move frame by frame as you like. So this is a nice way to remove the systematic error of human reaction. You could also use motion detectors or photo gates if you have access to those things. Those are nice ways to avoid the problems that come up with using stopwatch. Okay, so plenty of improvements to my method. Even though the method gave us some pretty convincing results, there are always improvements that we can make. When it comes to extensions, the goal is to learn more about the situation that your experiment is revolved around. So I have a couple examples of that here. One possible extension would be, instead of changing the hanging mass throughout the experiment, we could keep that constant and make the new independent variable angle of track. So in other words, we could adjust the angle that the track is at and see what effect does that have on the acceleration of the cart. And this would be useful, and it would help us learn more, because in our experiment, I think we can be pretty confident that increasing the hanging mass was increasing the net force and hence increasing the acceleration. of the cart. So if we were changing the angle of the track, that will help us understand better how does the net force change depending on the slope of the surface that something is resting on. Another extension that we could do would be to use a wooden block instead of a cart. Now, it's not obvious why we would do this, because the first thing that you would think of is, well, those carts are great and they have very little friction, so why would we want to take them out from the experiment? Well, that could be an advantage, because if we used a wooden block instead, it could help us to learn how does having a significant amount of friction affect the acceleration of an object. And hence, then we can learn more about how does the friction affect the net force acting on the object. So I'm sure that there are plenty more improvements and extensions that could be done for this experiment. These are just the ones that kind of popped into my head early on. What's important is that you have identified specific improvements and given reasons for why they will minimize errors in your method, and you give specific extensions and give specific reasons about what they will help you learn more about this situation. If you come up with other interesting improvements or extensions, feel free to write them in the comments. Bye-bye.